For this demo, I downloaded a very small snippet of data from opentopography.org in ASCII format over Half Dome in Yosemite. I'm going to navigate to the location. I've extracted that into a text file. I can see the preview here. I'm going to select the output folder. Okay, and notice I can see in the preview window, I can see the column headings, or I may also want to go ahead and open this in something like Notepad so that I can see it all on my screen at a particular time. But you see I have all of the headings there corresponding to the data records that are in the file. Okay, so next there are commas that delimit the fields, so I'm going to say it is delimited and let it know that it is a comma, and as soon as I do that I actually see my data separated into columns and I still see the headings at this point. So that's going to be a problem. I need to back up and make sure that I ignore the headings because those are going to not be recognized as valid data. Alright, and go back to next. I can still see the headings in the grayed out area, but those rows are not going to be imported. Okay, now this is the tricky part, is matching up the columns with the appropriate fields in the LAS file. So I have to go back and refer to this list, and it says column 1 is the X coordinate. So I click on column 1, and then I click on the radio button for X coordinate. Notice now the text has changed in the selector box, and it also changed in the preview. You can see that second row there, it says X. Likewise, column 2 is Y, column 3 is Z, column 4 is class. Now I have to scroll over, and at this point it becomes a little bit, I can scroll over here too. Column 5 is GPS time. Column 6 is scan angle. There's no option to import that, so I'm going to skip that, just leave that as unknown. Column 7 is intensity. Column 8 is number of returns. Column 9 is return number. And then if you scroll over, you'll see that there are columns for red channel, green channel, blue channel, but in the data itself those are not populated, so I'm going to ignore those. I'm going to export to LAS version 1.4, and because in this case the files are classified, remember we had column 4 was class, then I'm going to not check that box. I'm going to retain the classifications that are in the text file and just simply press finish. Alright, once the import is complete, then I can add that data to LP360 in LAS format. So I'll add my layer, navigate to my file, everything checks out. There's no coordinate system information contained. Remember that we had no metadata, no header information at this point. So I'll simply say OK, and there it is. Alright, well that's the end of this demo.
Next I have a Mr. SID compressed MG4 file, LiDAR point data, called mosaic.sid that I downloaded from LizardTech. This is a sample of some LiDAR data over Mount St. Helens. So I'll use the LP360 import tool, and I'll simply add the file, select my output folder, and I'm going to write this to LAS version 1.4. And it takes a few minutes to convert. When the import is complete, I can then add the file. I'm not going to worry about this warning that the number of points in the header does not match the number of points that LP360 has actually counted in the file. It's just a warning, not a um, it's not a red X, so I can continue. And when we take a look at that in TinView, it's much more interesting. There we go. One last thing to note is the relative size of the files in different format. So that Yosemite data in the ASCII format was about 58 megabytes, and in LAS it's 22. Likewise, look at the Mount St. Helens data that's in the compressed Mr. SID format. The SID file was about 120 megabytes, and the uncompressed LAS is 1.5 gigabytes.